Hello, everyone. Welcome to another session of Azure Administration Study Series. Hello, Sir David. How are you doing?
Your mic sounds great today. Sounds
Excellent.
awesome.
Yeah, it looks like the work I put in really came out on top. So
I,
that's really good.
I credit Aquasino on you.
Yeah, yeah, yeah. I think probably he reduced the volume or the mic for some reason. So
No, I credit him for fixing
yeah,
it. Boy's a genius.
yeah.
Yeah.
So hope everyone had a wonderful day. And thank you for taking some time in your busy day to join our session. And we know that you actually are going to learn a lot. I mean, from Sir David, he never disappoints. Right.
Yeah. Once in a while, it's because I've got people like you. That's
You
why.
always want to deflect it, right? Yeah.
Yeah.
So, Sir David, what do you have? What do you have for us today?
So today will be about Intersite connectivity, right? That's what we want to cover today. We want to look at Intersite connectivity. But we still have sort of like a little bit of leftover from yesterday
Yesterday, all right.
that we just want to delve
Screen
a
for.
little bit into and see if we can sort of pass on some useful information on those.
Absolutely. Yeah.
So let me bring up my screen and then we'll just go for it. We'll just go for that right then. So I know that you're currently preparing for your Azure Architect exam, the second one. How is
Yeah.
that preparation going? How's it going?
Yeah, I mean, so far, it's just taking a bit slow, but yeah, I'm still covering the content bit by bit. So it's been great. Actually, I think once you complete the AZ 303 and understanding the technology and with the design, it's that everything starts to piece up easily. So it's really good that once you've done the 303, follow up with the 304, and then you everything will start to make sense much more.
Yeah. And also, like, what's your plan afterwards? I'm asking this in case someone is watching and they're thinking, okay, if I'm currently studying with you guys, studying with us, doing the Azure Administrator certification, and once I finish that, maybe I do like the Azure Administrator. Like, what's your plan after that? After you like the Azure, Azure Administrator, Azure Architect, any further plan, or do you just carry on with that in terms of just doing those certifications, recertifying?
Yeah, I think I'll carry on because the more I do it, the more I learn continuously. So it's all about continuously trying to understand the cloud environment, and the only way you can actually carry on learning is doing it by having the habit of continuously engaging yourself with, I mean, and also challenging yourself with these exams and also these labs as well. So yeah, I'll carry on.
Yeah, that's my plan also. So at the moment, like I've got like nearly all the certification that almost all the Azure certifications and stuff, apart from the data ones. However, I used to say in the past, I used to say, Sarkoff, if someone were to ask me in the past, I'll say, yeah, I'm not like a data person, right? And stuff. But however, I'm beginning to develop interest in that. So it's very interesting. So who knows, we might see like an Azure data study series in the future. Okay. So this was where we stopped yesterday. So let's pick up from there. So yesterday we looked at Azure DNS resolution option, and we started by saying we have the default option. And the default option, we said it's Azure provided DNS. So, Kofi, just to, I put you a little bit on the spot here, but we do this to each other. So, we put each other on the spot all the time. That's how both of us keep growing. We put each
Yeah.
other on the spot. So, do you remember what sort of like the downside or some of the disadvantages of using the Azure provided DNS is? So,
I think I probably skip my mind a bit, but I
yeah.
think some of the downside will be the host name part. I mean, you cannot have your own one. Some part have to be random because everyone is using the same DNS. Yeah,
That's exactly accurate because if we use the Azure provided DNS, we'll be able to do DNS resolution for public names like google.com. That's going to work. We'll actually be able to do DNS resolution for hosts in the same network. And I showed that yesterday. So we can do DNS resolution for hosts within the same network. However, we can also do reverse DNS lookup. However, we don't have any control over this. We cannot control it, right? It belongs to Microsoft. It's managed by Microsoft. It's provided by the Azure platform. And the Azure DNS created suffix that we have, like what Sarkofi mentioned, that DNS suffix cannot be modified. So the DNS suffix will be in the form of random character .internal.cloudapp.net, and we can't modify that. So essentially, her names will be web01. All the other stuff. So the other downsides to it is only scoped to the virtual network. So let's talk about that. So what this means, Kofi, is that, so this is one virtual network that I have in Azure. What happens if I have 5 of them, right? So I have virtual network 2, I have virtual network 3, I have 4, and I have 5. I have all these virtual networks everywhere. Well, Azure provided DNS is scoped to this network. So these ones will be able to resolve each other's names, right? These instances. Instances here will be able to resolve each other's names, right? To one another. So they'll be able to resolve each other's name using the Azure provided DNS. I'll just say APD, Azure provided DNS. However, this instance over there cannot resolve the DNS name for this instance over here with Azure provided DNS. So it is scoped to that virtual network. And we cannot manually register our own records, again, to what Sarkofi said. So yesterday, we now carried on with that conversation and said the other option that we have is the customer managed DNS server. So this is where, as a customer, I can go to deploy a DNS server inside my Azure network. That could be a Windows DNS server. That could be a Linux DNS server. It could be any DNS server, right? As long as it's running the DNS application.
Yeah.
And once I deploy that into my own network, then what I can do, Sarkofi, is if I go over here, so if I go over to virtual networks, over here I have 3 virtual networks. So let's pick this one, the UK South VNet 01. And if I go under the DNS server settings, I can go to switch that from default and switch that to custom. And then I put in the IP address of my own DNS server. So let's say my DNS server exists in this network and the IP address is 10.1.5.4. I put in that IP address there and I can add another one. Right? If I have 2, okay, I can add another one.
So and essentially, then, this will act like what you might have in your on-prem environment.
Yes, but this is just a virtual machine that I have hosted in Azure, or a virtual machines that, or just an instance, an IP address that my resources can reach that they can use to resolve DNS. So that's what that is.
Okay.
Yeah, and actually, if I have VPN connection from this network to my on-premises resources, I can just point to my on-premises DNS server and use that also. So that's also supported.
Okay. What about I have, let's say, a virtual appliance for let's say firewall, a third-party firewall, and I want to use that as a VPN. Is that possible as well? So for us, it's in the same network that is possible. Is that correct? All right.
Yeah. Yes, absolutely. That's possible. Okay, so do that, Sarkofi, so we can configure our own custom DNS server. But we mentioned that in order to simplify things, we may want to enable DNS forwarding to say, hey, my DNS server, if you cannot resolve certain names, just forward it to the DNS server over here. It will resolve those names for you. So this DNS server being Azure provided DNS. So now the question that we stopped on yesterday was this. What's the IP address that I'm going to use on my DNS to say forward to Azure provided DNS? And that was when this IP address came forth, 168.63.126.16. And that was where we stopped. And the question we're trying to... Yeah, carry on.
I've got a follow-up question here. So does it mean that on your managed DNS server, right, when you're creating the forwarders, you just have to specify that IP address and then it should be able to find it?
It will be able to find it if it's inside an Azure network. If this DNS server is in an Azure network, you'll be able to get to that. So, and that's a special IP address that's used by the Azure platform for many purposes. So you see this IP address not only on the DNS, you see this IP address on the load balancer in configuration. You see this under, if you're doing like the Azure VM agent communication, this IP address is used for that. So actually, I have over here the documents that I brought up yesterday to show to people on what is this IP address. So let's go to that document and let's go through it very quickly together. So what is IP address 168.63.129.16? So this IP address is a virtual public IP address used to facilitate communication to the Azure platform resources. Okay, that's a lot of like English and stuff. What does that mean? Let's take one of the points. For example, this IP address enables communication with DNS virtual server to provide filtered name resolution. Another way to put that is this IP address is the IP address that you need to communicate with for Azure provided DNS. So that's what that means.
Right.
So, but it's also used for other things. So, for example, it's used for load balancer. So, for example, when the Azure load balancer is checking, we're not talking about load balancer now, we'll talk about it in the future. But when the Azure load balancer is checking the health of the instances that you're load balancing to, it's the source IP address would be that IP address over there.
Right.
So whenever people see that in their logs, don't think it's an hacker. It's the Azure platform communicating with your resources. Right. So that's what's going on. Okay. So now that we have that out of the way, so let's move on. So our customer managed DNS, we can use that to provide internal name resolution, for our virtual network. So we can resolve internal names. So let me clear up all the other stuff that I have on the screen. So we can use it to provide internal name resolution for VMs within the same virtual network. And so we can use that. We can use it to provide resolution of public DNS names. So our instances will forward the request to our DNS. Our DNS will forward the request to Azure provided DNS. Azure provided DNS will forward it to the internet, just like what I just showed just now, right? It's going to go that flow, come back. There we go.
Right.
So what other options do we have? We have the Azure DNS private zone. So which is the one that Sarkofi showed us in the lab that you put out. So Sarkofi, by the way, I must say that was an awesome lab content that you put out there. It was expertly done in Sarkofi's manner. But the only thing that was a bit disappointing to me was I did not see your gold chain.
Oh, no,
gotta show your blink once in a while, because otherwise people are beginning to look at me and they're beginning to doubt. They
should.
No, they should not.
They should doubt you.
They should not do not doubt. I tell you, do not doubt what I'm talking about. I tell you, one of these days we'll take a picture of the gold farm, send it to you, and do not doubt that that statement. So Azure DNS private zone. So this is essentially a DNS service that we don't have to manage the infrastructure. That's the advantage. So essentially, I want a DNS service. I don't want to manage operating system, manage DNS application. At the end of the day, what do I use a DNS service for? I want to do name resolution. Why do I need to manage operating system patching and application patching just to do name resolution? So that is what this service is about. This service is about create a DNS service, attach it to your virtual network. So when you attach it to your virtual network, then you can do other things like you can have multiple virtual networks. So if I have another virtual network over here, I can simply attach the same DNS service to it. I create another virtual network over here. I can simply attach this to it. So all of a sudden, all these virtual networks and the instances running in them can resolve the names of one another.
Yeah.
Because they are all connected to the same DNS service. So that's how that works. So let me quickly clear up the screen and let's go forward. So it even supports cross-subscription virtual network. So let's say this network is in subscription A. I have another subscription here called subscription B. I'll just call it subscription B. And subscription B has a network over here. No problems. I can still attach that network even though it belongs to a different subscription. I can still attach it to this DNS service. Let me go very quickly to just show people. Again, I'm not going to repeat what Sarkofi has already done. Make sure you go check out the lab that Sarkofi put out on our YouTube channel yesterday, and you get the point that we're talking about. So anyways, if I go over here and I go to create a resource, actually I can just go to search for DNS. And sorry, I can just go to search for DNS over here, and I can go to private DNS zones. And if I go to private DNS zone, I can go create a private DNS zone and put it in a resource group. So let's say I put that in my UK South resource group, give it a name. I'll say UK South DNS zone. Oh, it doesn't like, sorry, it has to be a proper name. Sorry, apologies. So let's go ahead and call these, Paris cloud.xyz. So that's the name for that, resource group location, that's fine. And I just go ahead and create this. And after I create it, I can attach it to my virtual network. And then, so you can do things like automatic name resolution. If a new virtual machine instance is deployed in my subnet, it will automatically register its record with this DNS service. So, and it automatically keeps that up to date for me. So that's one of the advantages of that. So while that is creating, I'll just go ahead to back to this. So what else can we learn about this so that we can move on to that? It supports auto registration that I just talked about. So whenever a new instance gets deployed, automatically registers its name. So, okay, let's keep that. So let's move further to talk about connectivity today. And we're going to break down some things that's confusing to certain people. Today's a coffee about connections within Azure Virtual Network. So by the way, when I create my DNS service, this is how I can go to link it to a virtual network. So if I can go over here, I can go to say, this is my UK South virtual network link. And I can go to, if it belongs to a different Azure subscription, I can go to switch that, or I can specify the resource ID. So whichever option I want to use, I go to pick my virtual network that I want to link this to. I can enable auto registration. So if I create a new instance, it will automatically register, and I click OK to that. And it's going to create the link between this DNS service and my virtual network. So that's the way that works. Okay, so here's the thing that we want to demystify, Sakofi. We want to really demystify and make it clear to everyone. How does communication works? Oh, okay, just checking that I've now switched off my mic. How does communication work in Azure with external services, or even with other internal services in Azure? So let's break it down. So let's start first with internet communication. How does communication work between my instances in Azure and the internet? So internet communication, number one. Outbound traffic is allowed by default. What does that mean? If I create a virtual network in Azure Sakofi and I have my subnets, I have my servers in that subnet, by default, they can communicate outbound unrestricted with the internet. By default, I don't need to do any configuration. All I need to do is create a network, create a subnet, and that virtual machine in that subnet can communicate with the internet. That's the default. Yeah. So let's see. What can we do to restrict this? We talked about this yesterday. We can use a network security group, Azure Firewall, or a third-party firewall like what Sakofi mentioned earlier. We can use that to restrict that communication. So I can go ahead and add a network security group at the subnet level or at the network interface level. And if I do that, that's going to restrict that communication, right? So that way I can restrict that communication. What else? I can also restrict that communication using an Azure firewall or a third-party firewall. So I can create a subnet Sakofi, deploy a firewall into that subnet. It has a public IP address. And I can now use a route table to force traffic that needs to go to the internet, to force them through this firewall. And then that way, any communication that's going to the internet will go through the firewall, and I can have restrictions over here. So to do that, I just use something called route tables. So I can associate a route table to that subnet, and the route table that I associate to it will say anything going to 0.0.0.0/0. I want you to send it to that IP address of that firewall. And then on this firewall, I can go ahead and implement all the security that I want to implement. So I can do the same thing for Azure Firewall or a third-party firewall. So that's how that works. So what other option do we have then? So let's carry on. So that way, if I restrict anything, it just stops it. The firewall stops it there. Okay. So what about inbound traffic? That's good. That's outbound communication. I know how outbound communication works. I know it works unrestricted by default. I can use NSG or firewall to restrict it. What about inbound communication? The way inbound communication works is you need a public IP address. And
That's
there are
right.
two main ways that people will associate that. So either you have a public IP address associated directly to the network interface of your systems, of your resources. So I have a resource. Let me go over here to the Azure portal. So I have my resource in the Azure portal. By the way, all my resources already have public IP address. I'll just show you where that's associated. So if I go to that resource over there, I go on the networking of that resource. I select the network interface of that resource and I go under IP configuration. So if I go over here, so this is where I can associate a public IP address directly to the network interface of this virtual machine. And if I do that, what that means is that the internet will now be able to communicate from outside to my resource through this public IP address. So that's how that works. So that is internal communication. What else do we have? Any other way that we can implement this? Yes. The other way that we can implement that is I can create a load balancer. Give the load balancer a public IP address. Then associate that load balancer to the network interface of my virtual machine. And now the internet can communicate with my virtual machine through the IP address of the load balancer and communicate with that. So those are the different ways that we have to make internet to internal communication work for Azure Virtual Network. I believe we have some questions in the
Yeah,
chat
let
window.
me bring it up. So here we go. So do we need to create a new resource group for every operating?
Very, very, very interesting question. Sakofi, do you want to go for that?
Yeah, I mean, I know. I mean, once you create one resource group, you can add all your resource into that. I mean, mostly creating a resource group have to have some meaning. So, for example, if you have a development and a test, you can create a resource with those specific names. Or if you have, many scenarios, but it have to be meaningful to the resource in. They have to make sense to the naming scheme, something like that. That's what I always do it. Yeah, but you don't need to create a resource group for each and every instance or resource you actually deploy.
Yeah, I completely agree with what Sakofi said. Couldn't have said it better. Awesome. And I think there's another question by Satish now. So Satish,
Yeah.
yeah. So
All
can
right.
we add a record for public IPs of Azure VM in Azure DNS? Is Azure DNS a NS or it does DNS delegation to external NS servers? Very, very good question, Satish. So the answer to that is yes. So Azure DNS, the one that I created just now is Azure DNS private zone. We can also create Azure DNS public zone. And when we create an Azure DNS public zone, that zone can act as as a delegation. So to your point, right? So it's not as if Azure DNS now becomes a DNS registrar. So that's not the way it works. However, you can configure on your DNS registrar and say Azure DNS public zone is now my name server for this name. So your point is correct. So it does DNS delegation to external. So essentially, it's not that it does. It can be a name server for your public zone, and then from your DNS registrar, you can point to Azure DNS. That. So a quick example of that is, let's say, over here. Let me quickly clear up the screen very quickly. Satish, excellent question. So I have my GoDaddy DNS name over here, and then I have my Azure public DNS zone. So I'll just say Azure public. I'll just do pub DNS, Azure Public DNS Zone. So what I can do is after I've created this, I can go to my GoDaddy name registrar and I can say the name server is the IP address for this. So anything that comes to try to resolve the name, it will use that as the name server. So it does support that. Yes. Hopefully that makes sense, Satish. So let's move on. Okay, so Kofi. So now that we understand how internet communication works, what other communication do we want to achieve in Azure? Let's go have a look. What about if you have multiple networks in Azure? You want them to communicate with one another. How does that work? So the easiest way to implement that is to implement something called VNet peering. So VNet peering is where you can connect two networks together in Azure for easy communication. So let's see some information about that. So VNet peering connects to Azure virtual networks together. The peering can be regional or can be global. What does that mean, David? Regional, global. What that means is have a look at this case over here. I'm connecting two networks that are in the same Azure region. So maybe this Azure region is UK South or West Europe. I have two networks there. I'm connecting them together within the same region. However, VNet peering can also can also be used to connect to virtual networks in another Azure region. So that's global VNet peering if you do that.
Okay, so making these type of okay, that's the answer right there.
Yeah. So yeah, go ahead with the questions,
Yeah, I was
Zakofi.
just going to say, okay, making these type of connections, is it going to rely on the public internet or there's another medium? And here
Yeah.
we have it right there.
Yeah, Joe, you're absolutely right, Sakofi. So it does use the Azure backbone for privacy and isolation. So it goes over the Azure backbone for that connection. And what that means is that it also has lower latency.
Okay.
The other good thing is we can actually peer networks across subscriptions. So again, I have subscription A over here, and I have subscription B. Subscription A has one network over here. Subscription B has one network over here. I can pair them together. Actually, even if they belong to different Azure AD organizations, I can pair them together, which is great. Because if
Yeah.
you can imagine, like, let's use a scenario. So someone has like a Bitcoin company, right? Someone's doing a Bitcoin company. So Bitcoin is growing these days. Sakofi did some mining on his gold farm in Ghana, got like some fresh gold, right? Some real gold out. Sakofi is like, let's buy this Bitcoin company, right? So you bought the Bitcoin company, they have their own Azure AD organization. Sakofi is like, what are you doing? Connect back to my organization because we own you now, right? So, you can connect across organizations and do VNet peering across that way. So that works.
Nice.
Yeah, awesome. So obviously, can you see? And anyone that's not
Yeah.
doubting me, did you hear what he said? He said, nice. He said, nice. Now I know what to do. Can buy that company and get them to connect their network to mine. So then, but here's the thing about VNet peering is that the networks cannot be the same. So over here, I cannot have this. If the network IP address space is 10.0/16 over here and it's exactly the same over here, peering will go, no, it's not going to work. They have to be
Right.
separate IP address spaces.
So that means the same apply for every network, even on-prem. If you are setting up a VPN, both
Yeah,
networks have to be unique.
that's true, sir. That's true. And one of the thing about that is that what that highlights is that it highlights the importance of planning. It
Yeah.
highlights that we need to plan our production networks in Azure properly to avoid a situation where there will be an IP address conflict. Right.
Okay.
So
But
that's what.
in a scenario whereby, let's say, customer A and customer B, they don't want to change, is there any way you can use nothing for this purpose?
Not nothing. There's a way that you can do because of Azure Network is software defined. It's flexible.
Yeah.
So one of the ways that organization could potentially undo that is, so for example, if I go to a virtual network that I have in Azure Coffee, I have a virtual network over here. And it has this address space. I can go ahead and add a different address space to it. So this is address space of 10.1 software defined networking. I can just go ahead. Now you're going to have 192.168 dot 2.0/24. And that's
Okay.
going to be part of your address space. And then I can slowly transition my instances to that address space. And then at the end, after transitioning my instances, I can retire that address space.
Okay. So
Yeah.
essentially, clients that are part of these VNet, they will have two NICs.
Oh, no, they won't have two NICs. So they will only have one NIC, but their IP address will be that. But then I can use either a PowerShell command or I just say like to automate and assign this IP address space to them statically, right?
Oh,
And then essentially move them over to this. And then essentially I can get rid of this afterwards.
oh, got it.
Yeah. So that's how that works. So let me quickly go show how VNet peering would work and how I would configure that. So if I go over to my Azure portal environment, so what I have over here, Sakofi, if I go under virtual networks, is I have two virtual networks. One is in UK South, one is in West Europe. So you can see UK South, West Europe. And the UK South virtual network is has an IP address space of 10.1/16. The West Europe virtual network has an IP address space of 10.1. Sorry, that's 10.1/16, right?
Yeah.
I think they have the same. Do they have the same or different ones? Oh, that's 10.1/16. So I have another one that doesn't have the same one. So let's go check that out. Yeah, there we go, 10.0/16. So those are the two that I want. So I want this one and this one. I want to pair them together. So this one can be a bit confusing. But anyways, UK South VNet and West Europe VNet. Okay, so if I go, I can do it from any one of them. I can go to West Europe VNet, UK South VNet, and then I can go under VNet pairing. And under VNet pairing, I can go to add a pairing relationship between them. So let's say this is doing this from UK South. So let's say UK South VNet to West Europe VNet. So that's what I have. Traffic to remote virtual network allow. We'll talk about what this is in a minute. And one of the good things that Microsoft has done is they've simplified it. So in the past, I'll have to configure the pairing over here and then go to the other side to configure it. But Microsoft has simplified it to where I can just configure both at once. So I can go to switch this one and say this is West Europe VNet to UK South VNet. And that's for the other side, right? And I can go specify the network I want to pair with, select my West Europe VNet. I'll talk about the settings later. And if I go ahead and say add, so there we go. So it's going to add the pairing. It's not going to take a long time. Again, Sakofi's lab will walk you through this with the instruction that we put out, and then that's going to help you to understand that. So once it finished validating, the pairing will be connected, hopefully. So that's how we do VNet pairing across that. So that's another one. So let's go to have a look at some other information regarding this. So here's what I've just done, Sakofi. So I've just added that pairing relationship to my virtual network in West Europe. And once I've added that, then communication should be able to go through amongst them. But what exactly happened in the backend is the question. What happened when I did the virtual network pairing? Let me show you very quickly what happened, Sakofi, because there's some very interesting thing that Microsoft did. Now, every network in Azure has, a subnet in Azure has a route table. The route table defines how traffic will be routed. So if I go over to the route table so you can see that it's now connected, right? If I go over to have a look at the route table of one of the virtual machines, so let's go to this virtual machine that belongs to one of those subnets. So let's go under its networking, let's go under its network interface, and let's go check the effective routes. And let's see if anything was changed by me adding VNet pairing. So the answer to that is something changed. The question is, what's changed? So let's see. Can you see something here, Sakofi? Yeah, there's a new route entry that was added automatically that says anything going to that other network, the West Europe network, 10.1.0.0/16, send it via VNet global pairing. Why VNet global pairing? Because it's in a different region. So that's why. So it automatically adds a route entry to allow that. So that's what we're talking about.
If the it's actually in the same region, then you won't see this VNet global pairing.
Yeah, so because we have regional pairing or global pairing, so it's going to be region pairing.
Regional.
Yeah. So that's what it does. It just adds the route entry. So essentially, after we've done that, they know how to route traffic to one another. So let's go quickly test that out. So I have my virtual machine over here in West Europe. What's the IP address? 10.0.0.4. And I have this one over here that's in UK South, this in West Europe, that's 10.1.1.4. So I'll go ahead and connect to one of them. So let's connect to the one in UK South. So let's copy that IP address range. Let's bring up PowerShell that has SSH. I'm just so excited about that. PowerShell with SSH. It's so cool. It's absolutely cool. So let's do SSH Azure admin and that. Oh, sorry. What am I doing, Sakofi? Sakofi, and you let me do this. No, you're not to blame. So I'm putting the private IP address. Of course, it's not going to
Oh
work.
yeah.
I need to connect to the public IP address. So sorry. So sorry. So let me go get the actual public IP address and let's clear the screen and let's do that again. So SSH Azure admin hat that, and that should work now. So yes, and put in my password. And if I do an ifconfig, so that's 10.0.0.4. Now I want to connect to the VM in West Europe, which is 10.1.1.4. So let's see. So if I clear the screen, clear the screen. So let's do a ping 10.1.1.4, and now they're communicating with one another. I can still go ahead and block the traffic using NSG if I wanted to, but essentially they can communicate with one another.
All right. Nice.
Awesome. So Sir Kofi, what I want to do is I want to go ahead and show this one. Sir Kofi, I know that you're a fan of F1. Is there any F1 games going on this weekend?
No, actually, next 2 weeks.
Next 2 weeks.
That will be Monaco. So
Oh, okay.
I can't wait.
What happened? Who won with this week's F1? The one that you were watching on Saturday.
Actually, Lewis won. I think for the past two race, Lewis have actually won.
Oh wow!
Yeah.
Wow. The guy is good, man. Sarkofi, the guy is good.
Yeah.
That's Sarkofi level. That's the kind of people that Sarkofi relates to. Right? It's a different lifestyle.
Yeah, you should definitely watch F1. You find it nice.
That's rich man sport, man. Sarkofi. Golf, F1. That's when you're on a different level that you.
Yeah. Actually, we got a question here. Let me just bring it up on the screen.
Let's say that.
There you go. Can I use my pay-as-you-go subscription for the labs? Absolutely. You should be able to. Yeah.
Yeah, that's correct, Sarkofi. I agree with you. And I think Damendra, apologies, Damendra, if I'm mispronouncing your name. I think he also has a question. Oh, okay. He says, I think you can do it via private link services. So I'm not sure what the context is to that. Damendra, if you want to, please clarify that. That'll be good. Okay, Sarkofi, so we only have a few minutes, so let's quickly talk about hybrid connectivity and other things. So what about hybrid connectivity? We have an on-premises network we want to connect to Azure. What options do we have? Well, the first option is through VPN gateway. What does that mean? So here's how that works. I have a VPN device on premises. That could be a VPN device, which is a firewall. I have that on premises. On my Azure virtual network, I create something called a gateway subnet. And that subnet has to be called that name. It cannot be called any other name. It has to be called gateway subnet.
So with a gateway subnet, is it totally different from the normal subnet, or it's just namesake? You just name it gateway subnet.
It's not totally different. So the reason for this, Sarkofi, is because of Azure automation. Because if we're using Azure VPN gateway, which is what we're referring to here, the devices that are going to be deployed into this subnet are managed by Microsoft. These are not customer managed devices. Microsoft automation has to be able to reach this and manage it easily. So that's why it's got to be the name that it needs to be.
Oh, got it.
Yeah. So you see this not just for gateway subnet. If you want to deploy an Azure firewall into your network, it has to be called firewall subnet. It cannot be called any other name. If you want to deploy an application gateway, it has to be called the particular name that Microsoft wants it to be called, because these are services that are managed by Microsoft. However, they exist in a customer's Azure network. So that's the reason why.
All right.
So let's go ahead and quickly view this. So let's go ahead and clear the screen. So let's go ahead and, after I create the gateway subnet, I can go ahead and add the VPN gateway to it. The VPN gateway is going to have a public IP address. So I'll just call that PIP for public IP. And then when I have a public IP address, I can go ahead and connect them to one another. So that's sort of like how that works. So I can connect them to one another.
And what sort of, VPN sort of like can we use? Is it just IPsec or can we use any other type of VPN?
Good question, Sir Kofi, because that's exactly what the next slide talks about. So there are two types of VPN. So we can do site-to-site connection. We can also do point-to-site, which is user VPN to that gateway. So we can do that. However, to your point, so there are different gateway types. So we have route-based VPN, which supports IKV2. So 1 minute, Sir Kofi, I'll be back in 1 minute. Sorry. So
All right, guys, apologize for this. So David have an emergency that he need to attend to. He should be back momentarily. All right. Here we go.
hello, apologies about that. I just had some sounds that I needed to go take care of. Sorry about that. Okay, so we have the route-based VPNs. So essentially, I'm not sure why Microsoft did this. So this just adds confusion because when we say route-based VPN, essentially what you're talking about, it supports IKV2, right? When they say policy-based VPN, they're talking about IKV1. I think they should have just called it IKV1 gateway, IKV2 gateway, but confusion and stuff. So when you're creating your VPN gateway, you can select one of these options, route-based or policy-based. If you select route-based, you can do IKV2. You can use dynamic protocols like BGP. If you select policy-based, you can do IKV1, and you have to manually define the sort of like the routing for that. So that's sort of like the options that are available to us. So in terms of the gateway SKUs, Sarkofi just quickly pointed that out. So in terms of the gateway SKUs, this is what they look like. So they have different sizes, different generations. So you have essentially just the main thing to know is that for all of them, the maximum site-to-site VPN tunnel that you can have is 30, right? So you can have a maximum of 30 site-to-site VPN tunnel. The throughput benchmark depends on the SKU that you select. So you can go all the way to 5 gigabits per second, starting from 650 megabits per second. But these are not like as if they are guaranteed. These are sort of like a benchmark that they've done, right? So the gateway SKU affects the connection and the throughput. Resizing is allowed only within the generation. So for example, you can change the size of your gateway from this size to this size because they belong to the same generation. But you cannot change the size from this size to this size because they belong to different generations. So they have to be the same generation for you to do that. Okay, so I think that's really enough about Azure VPN Gateway. Let's quickly talk about some other information about Azure VPN Gateway. So here's the scenario, Sarkofi. I have my on-premises network, right?
Yeah.
I have my gateway subnet, and I've deployed my gateway into that subnet, and I've done my VPN connection. I do not want to be having VPN gateway for every single network that I have in Azure, right? I want to centralize things, right? So this essentially becomes sort of like what people refer to as the orb network. I want to have a single orb network where I can define my connectivity to the internet, my connectivity to my data center, my remote data centers, and every other network that I have in Azure all communicate through that hub. So this will be called the spokes.
Yeah.
So how do I do that? So with this scenario of VNet peering, we can achieve this scenario. Because what we can do is, let's go to have a look. Here is the link on the site. So let's go back. So gateway VMs are deployed to the gateway subnet. So we already know that. So we don't deploy any other resources into that. So we want to avoid associating NSG. But here's what we can do, Sarkofi. We can, when we are configuring our VNet peering, one of the settings that we have is a setting to allow this network over here to use this gateway over here. So we have to enable that when we configure our VNet peering or afterwards, right? So we have to enable that. Another setting that we have is a setting where we can say if traffic is coming, let's say from the internet, coming through this firewall and wants to communicate with this instance, where we can say, I want you to allow this traffic to pass through you to communicate with this instance over here. So those are two settings that we have to specify when we create our gateways. Let me quickly go to, let me create a peering. So let me quickly go
Sure.
to show that on how we specify those. So if I go over here and I go to my virtual network and I go over to peering, let's go see how that works. So my UK South virtual network, and I'm going to go bring up peering. Peerings over here. I'm going to select that peering connection and I'll show those options to you. So you see this option, traffic to remote virtual network that's allowed. But you look at this, traffic forwarded from remote virtual network. In other words, traffic that, let's say, coming from the internet or coming from my remote data center that's coming through a peered virtual network to talk to me. Do I want to allow that or not? So that's what that means. So I have to set that to allow in order for that to work. If I set that to block, then this communication flow that I just showed to you now, in terms of this traffic that's coming from the internet, this would not work if I disable this. So I have
Got
to
it.
allow that. Right. And this is the one that I will specify if I want this instances over here to be able to use this gateway to communicate through here. I have to enable that. So because I don't have any gateway, that's why it's set to none and all that stuff. So,
Got it.
okay. So let's see. I think there's some other question and then we
Yeah,
can round
we've
off.
got a few questions here, so I'm just going to bring out the first one on the screen. Right. Is it applicable same subnet not able to make peering for different subscription or Azure account?
No, they can. So even if they belong to different subscriptions or they belong to different Azure AD tenants, you can pair them together. So VNet peering works across subscriptions and across Azure AD accounts.
Yes. Okay, so the next question is do we have to set up a rule for firewall for VPN peering for public IP?
So rules for firewall for VPN peering, I guess you're referring to VNet peering for public IP. I don't get that question. I don't understand that question. Can you help me to understand that question, Perit? So I don't understand what you're asking in that question. So somebody's asking about deployment of Sophos Firewall. Yeah, you can deploy Sophos Firewall, Palo Alto Firewall, and other firewalls. So essentially, you can deploy any third-party firewall to replace the Azure Firewall if you want to. So
Exactly,
yeah,
because we have these in the marketplace, Azure Marketplace. So once you go to the marketplace, you can search for, let's say, Sophos firewall or Palo Alto firewall, and it should come up. And then you just have to deploy it, and then you have to use the routing table to point your devices or your network to pass through these firewalls.
yeah, awesome. So South Coffee, now we are moving towards the end. So after you talk about this, just one more topic and that's it. So, and then we can introduce people to the lab. So what other option do we have apart from VPN gateway? We have the Express route. So ExpressRoute is sort of like what you call like sort of like your MPLS, right? So private connection between your on-premises network and Microsoft data center. But how does it work? It actually works in a similar way to VPN gateway. So here's how it works. So let's go back. We have our devices on premises, of like our firewall devices, or our VPN devices on premises, or our routers and everything like that. We have our gateway subnet in Azure. It's still the same gateway subnet that we're talking about. So actually, let me go to show you about the gateway subnet. Because if I go over to my network over here, if I go over to on the subnet, it actually has an option where I can go to add gateway subnet from here. And you can see that it grayed out that name. It has to be called that name of gateway subnet. So I can create my gateway subnet, go ahead and save that. Whenever I'm creating my VPN gateway, so if I go to my virtual network gateway, and if I go to create one, it's going to give me the option to say what gateway type do you want to create? Is it for VPN? Is it for ExpressRoute? So it's the same gateway subnet that we are using for VPN and for ExpressRoute. So in this case, I'm creating a gateway subnet, but for ExpressRoute. And then it's going to deploy an ExpressRoute gateway into that subnet. The ExpressRoute gateway will connect to devices known as the Microsoft Edge routers. So this ExpressRoute will have connections to the Microsoft Edge routers. And the Microsoft Edge routers will not be one. So this is redundant communication. There's actually going to be multiple instances of this gateway making redundant communication with the Microsoft Edge routers. And now on your customer side, you have to go speak to your ISP. Your ISP, you speak to them, they deploy edge routers on your site, you connect to the edge routers of your ISP on your site, and then you have that communication over the ExpressRoute circuit to the Microsoft Edge routers, and then you can use BGP peering to define how to get to your network over here through this. So that's sort of like how it works in the back end. So you have
Okay.
Microsoft Edge routers, you have your ISP Edge routers, you have the ExpressRoute connection going over them.
All right. So that means creating express routes is not just on Azure and then you're good
it's
to go.
it's Sarkophil level stuff.
Yeah, I
Right?
can
So
imagine.
pick up the phone, call some of your tech friends that have all these ISP providers.
Sure.
They'll get it set up for you and you're all good. So that's sort of like how
But
that
what
works.
about if, let's say, the customer have multiple sites? Can they still use ExpressRoute across multiple sites?
Across multiple sites? Yes, is the answer to that question. Now, that is an Azure Architect question, which there's some amazing slides that we have in the Azure Architect that I'll cover when we get to that live study. But the answer to that is yes. There's a lot of consideration from the architecture perspective. So, like what Sakovi said, you have a site you're using Azure UK South region. So let's say your ExpressRoute gateway. So this is in UK South. But let's say you're a global organization. You're also using the US region. You're also using one of the regions in Asia and in Africa. So how do you do that, right? Do you have to have ExpressRoutes across to all of them? Yes, you can if you want to do that. What if you don't want to have across all of them? Are there ways around? Yes, there are ways around on how you can architect that. But that is beyond the scope of what we really want to get into. It's really, really detailed conversation. Yeah. Okay, so let's look at the different peering types. So ExpressRoute, just be aware that it includes two independent peering, so private peering and Microsoft peering. What does that mean, David? Here's what that means: is that ExpressRoute is not just for connecting to your Azure network. ExpressRoute can actually be used to connect to Microsoft cloud services like Office 365, Dynamics 365, and the Microsoft platform services. So the way that it works is that when you are working with your ISP, you can define sort of like the BGP and peering that you want to set up. If you set up Microsoft peering, is actually going to advertise the public IP addresses of Microsoft cloud services through your Express route for your network to be able to reach Microsoft cloud networks through your Express route. However, you can also use it you can also set up Azure private peering, which is for your own private network. So in which case, your network IP address ranges will be advertised through BGP so that your customer on premises network can reach your private network through that way. So there are two peerings. There's private peering for your private network. There's Microsoft peering for Microsoft cloud services.
Got it.
Yeah, and also connectivity between the partner edge and the Microsoft edge is resilient, right? So if you notice over here, there's two connections all the time. There's two circuits, so it's never one, right? So again, this is beyond the scope of this course. This is architecture thing. So essentially, you need to ensure that you also have that redundancy on your side over here, because if this is paired and all of a sudden you have maybe a single router or on all the other stuff, then there's some other issues. So other things to consider would be maybe having two ISP providers instead of one for redundancy. But those are, again, conversations for the architect stuff for later.
Good.
So, and when you're creating your ExpressRoute, similar to the way that we can select our bandwidth, right, Sakofi, when we're creating our VPN gateway, and we can say, oh, I want VPN gateway SKU 1 generation 2, and I can get like 650 megabits per second. I can also specify the bandwidth for ExpressRoute when we're creating it, right? So you pay for that with your ISP, whether that's 50 meg, 100 meg, and the other ones. And the good thing about them is that we can co-host them together. So I can have my gateway subnet, I can have VPN gateway and ExpressRoute gateway in there. So maybe I'm using ExpressRoute gateway for primary connection, but if there were to be a failure, I can fall back to using VPN gateway.
All right.
Okay, so let's bring all of this to a close. So final topic. Oh, actually, I have just 2 minutes.
Yeah.
There's
So we've
and
got some few questions, but after this, I'll bring them on the
oh,
screen.
let's answer the question and then we'll do the final one. Yes.
Yeah. Okay, let me just bring this up. One moment. Yeah. So I said, why do you require /24 for gateway subnet when no VMs are going to be placed in that? I think in the real world, they more obviously narrow that down
Yeah.
to a lesser.
I agree with Sakofi, yeah, and I agree with you, Satish. So you don't have to. You can make it smaller if you wanted to. So that's fine.
Yeah.
Yeah. So there's another question in the chat window I see from Izuchuku about hosting a live.
Yeah.
Okay, no,
So
sorry.
we got one here. Can we have any sessions on designing high availability architecture?
Yes, we will. So this is currently the Azure Administrator live study. So we are studying towards the objective of the Azure Administrator. But right after this, we'll be going through the Azure Solutions Architect and we'll get into details. I'll tell you what we'll cover in those series, Vijay. We're going to be looking at architecting in Azure for different services from multiple level of performance, availability, scalability, security, and other points like having your support and SLA. So we're going to look at different architecture points for architecting different services in Azure. So we'll do that, but not in this one. We have to sort of scope the different topics that we are going for.
That's
And there's
right.
another question by Izuchuku. I want to correct
You want,
Izuchuku a minute. He said,
yeah, you
David,
want to do
could
one
you
to one.
host? Yeah, he said, could you host a live interaction in the future? A one with you will be awesome. Izuchuku, you're getting it wrong. What you need is not Azure knowledge. What you need is gold. What you need is gold. You need to connect to Sakofi. That's what you need to connect to. Forget all this Azure stuff. I tell you, what you want is gold and Bitcoin. Talk to Sakofi. So yeah, we'll see. Again, Sakofi. If he tells me, writes the check, why not? anyway, anyways, Sakofi, I'm not sure that we're going to cover this, but I'm just going to tease it and then we're going to stop for today. So there's another type of communication that many people don't really think about, which is communication with platform services in Azure. What happens if I have my virtual network in Azure and I have services like Azure Storage, Cosmos DB, Azure SQL Database, and all these other platform services? How do I do communication amongst them? Because by default, communication to platform services in Azure goes over the internet. So you have your virtual server, you have a virtual machine in your subnet in Azure. It wants to store data in an Azure storage account in the same subscription. By default, it goes over the internet. There are ways that you can solve that. One of these ways is to use something called service endpoint, which will essentially ensure that communication goes over the Azure private WAN. But we are out of time already, so we'll have to take this on in the next section. So in the next topic, when we start next week, what we're going to start is we're going to start with that. So I'm going to complete that. And after that, we're going to talk about the other topic we're going to cover will be network traffic management. So next week we have two sessions, Monday and Tuesday, network traffic management and Azure storage. So this will be awesome. I think that we're actually going to be having a guest speaker, Sakofi. I think we're going to be having a guest speaker. So look forward to that. I think that'll be awesome. But anyways, Sakofi, you have something for us today.
Yeah, so thank you guys for joining the session. So after this session, one of the things that we do encourage you to do is the lab for each session. This will drive the message home, essentially. So David, if you have the slides, if you can bring it up. So for the labs that we have, these are the objectives.
Oh, sorry.
So,
I think I got the wrong one. Sorry. Let me bring
yeah,
that
the
up.
lab
Yeah.
5. Yeah. So what we're going to do is, right, as David obviously have gone through with this lab, is to set up peering essentially. So what we are doing is that the first steps is that you have to deploy three virtual network, two in one region and one in another region. And then once you've done that, you set up you set up a virtual network peering, a global one and also a local one to obviously demo that sort of peering. Then after, you can test it using just a simple pin or checking for a specific port on those services. So I hope you guys I encourage you to do it because definitely this will drive the message home.
Awesome. So thanks very much again for putting out that content, Sir Kofi. Thanks very much,
No
everyone.
worries.
We've really enjoyed the series, so we are right on the time.
Yeah.
See you all next week. Have a lovely, lovely week, rest of the week, and have a lovely weekend. And see you
All right.
next
Thank you,
week.
guys. See you.
Thanks. See you. Bye.